Okay, so question number 8 is another Lewis structure question. What is the acceptable Lewis structure of ozone, which is O3? So again, we are going to start off by finding the total valence electrons. So for oxygen, there are 6 valence electrons. And since there are 3 oxygens in O3, we're going to multiply it by 3, and we end up with a total of 18 valence electrons. Okay, so now I'm just going to draw all my oxygens out like this. So with each bond, there are 2 electrons involved, so right now I have 4. And the next thing I want to do is just write out all the valence electrons on oxygen, the terminal oxygens. Okay, so let's count out how many this is. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So you can see that this is already too many electrons than we need. So I'm going to erase one lone pair of electrons from one of the terminal oxygens. Make a double bond. And we want our molecule to be neutral overall. So if we have a positively charged oxygen, then one of them has to be negatively charged in order for it to be a neutral molecule. Okay, so let's see what our junior tutor said. A Lewis structure is the representation of the arrangement of valence electrons among the atoms in the molecule. Some guidelines in writing Lewis structures are to sum the valence electrons from all the atoms, use a pair of electrons to form a bond between each pair of bound atoms, then arrange the remaining electrons to satisfy the octet rule. So note that the correct Lewis structure would be the structure that would have the simplest formal charge. Let's apply the guidelines to ozone. The sum of the valence electrons for ozone is 18, since one atom contributes 6 electrons. Now we form the bond. So they used 4 electrons to make the 2 bonds, which leaves us with 14 electrons. The middle oxygen needs 4 electrons to complete an octet, while the other 2 oxygens on the sides need 6 electrons each. This means we would need a total of 16 electrons, which we do not have. So we form another bond. We use 6 electrons to make one single bond, and one double bond, leaving us with 12 electrons left to arrange around the oxygen atoms. The middle oxygen needs 2 electrons to form an octet. The oxygen on the right needs 4 electrons, and the oxygen on the left needs 6 electrons to form an octet. I think they mean on the right for this part. We would need a total of 12 electrons, which we have. Giving the electrons to the oxygen atoms, we get this structure. Now we assign a formal charge using this equation. So they have formal charge is equal to the number of valence electrons minus the number of electrons in a lone pair plus the number of electrons participating in the bond divided by 2. Formal charges from left to right are 0, +1, and -1. Check if this Lewis structure is correct, I guess. We give another 2 electrons to make the single bond into a double bond. The structure would be this. In this structure, the middle oxygen is already complete octet. The 2 oxygen atoms on the side need 4 electrons each. Now that we used 8 electrons to form the 2 double bonds, meaning we still have 10 electrons left, this means that we would have an excess of 2 electrons, which we cannot assign to any other oxygen atom since all of them would have complete octets. Therefore, this structure is incorrect, and the correct structure would be the previous one shown below, along with the formal charges. Okay, so this is the structure I have as well. So this solution is correct.